The James Webb Space Telescope, a marvel of modern engineering, has just delivered its most astonishing image yet. What appears to be shimmering, structured lights on Proxima b, a rocky exoplanet orbiting a star just over 4 light-years from Earth. These mysterious illuminations have sparked worldwide intrigue and stirred deep fascination within the scientific community. For many, this discovery could represent more than just a technical achievement. It might finally answer one of humanity's oldest and most profound questions. Are we alone in the universe? Could these lights be evidence of advanced life? Possibly, cities built by extraterrestrial civilizations. While such a claim is bold, the potential is too captivating to ignore. The revelation has shaken NASA and other space agencies, causing whispers of something larger than we understand. Rumors swirl, some even claiming a quiet exodus among agency staff. Though unconfirmed, the speculation only adds fuel to the cosmic fire. The focus now turns to understanding this alien world, its potential for life, and the stakes involved in discovering something truly unprecedented. Proxima b, once a theoretical dot on an astronomer's chart, has become a focal point of hope and mystery. Nestled within the so-called habitable zone of its host star, where conditions might allow liquid water, this planet is a tantalizing target in the search for life. But it's far from hospitable. The planet is tidally locked, meaning one side scorches in relentless daylight while the other remains frozen in perpetual darkness. It's a world of extremes, searing heat and bone-chilling cold coexisting. Yet, between these harsh zones may lie a narrow twilight band, a temperate ring that could theoretically support life. If so, any life here would be vastly different from anything on Earth, possibly thriving under bizarre and hostile conditions. Those eerie lights caught by the Webb telescope hint at something more structured than nature might produce on its own. While they could be geological or atmospheric phenomena, they could also represent something artificial, an idea both thrilling and sobering. Adding to the challenge, Proxima b is bombarded by intense radiation from its red dwarf star, which frequently erupts in powerful flares. These outbursts could strip away any protective atmosphere, making the surface a dangerous place for life. But if Earth has taught us anything, it's that life is stubborn. We've seen organisms survive in our planet's most extreme environments, from boiling volcanic vents deep in the ocean to radioactive ruins. Could life on Proxima b have developed ways to endure or even harness these brutal conditions? This is precisely what the James Webb Space Telescope aims to find out. With its unprecedented sensitivity and clarity, outclassing even the mighty Hubble by a factor of 100, it can peer into distant atmospheres, sniffing out signs of water, vapor, oxygen, methane, or even exotic chemicals that might hint at biology. Still, the answers are not guaranteed. Proxima b might turn out to be nothing more than a lifeless rock, raising more questions than it solves. Yet its importance remains. Orbiting a red dwarf, the most common type of star. In our galaxy, this planet is a window into a wider universe. If life can survive here, it could exist on millions of other worlds. Red dwarfs, while long-lived and efficient, have a temperamental side. Their sudden flares can sterilize nearby planets, posing a serious threat to anything trying to evolve on their surfaces. And yet, their abundance makes them essential to our understanding of the cosmos. About 75% of the Milky Way's stars are red dwarfs. If life can thrive in these harsh systems, the implications would be profound. It would mean that the universe could be teeming with life, hidden in places we once dismissed as uninhabitable. Of course, the thrill of discovery brings ethical concerns. As we advance technologically, the idea of sending probes, or one day, people, to distant planets becomes more realistic. But what if we carry microbes from Earth to another world? What if we unintentionally contaminate an alien ecosystem? Our own history is filled with examples of exploration gone wrong. From spreading invasive species to triggering ecological disasters, we must be careful not to repeat those mistakes on a galactic scale. Exploration must be guided by both curiosity and caution. Even if Proxima b is lifeless, it has already taught us something critical. Earth's ability to sustain life is rare, possibly even unique. Our planet's stable climate, protective atmosphere, and rich biodiversity are precious and fragile. In contrast, Proxima b's harsh conditions highlight just how lucky we are. As we battle threats like climate change, pollution, and habitat loss, this distant world serves as a stark reminder: there is no Planet B. While our eyes may gaze toward the stars, our responsibility remains here on Earth. The quest for extraterrestrial life also forces us to confront the Fermi paradox. The troubling question: if the universe is so vast, where is everyone? Some suggest that advanced civilizations self-destruct before mastering space travel. Others believe they deliberately avoid contact. Or perhaps we simply haven't looked the right way. Proxima b offers a chance to refine our search. Maybe life hides in the shadows, beneath frozen crusts, or within the clouds of toxic atmospheres. We must adjust our expectations and broaden our definitions of what life could be. Still, exploring distant worlds is not without risk. Even the act of landing a single probe could forever alter an alien environment. The story of Earth's exploration shows us that seemingly small actions can have far-reaching consequences. The stakes, when dealing with other worlds, are even higher. Yet our drive to explore is deeply human, an innate part of who we are. Every step into the unknown is powered by the hope that we might uncover something incredible. Life on Proxima b, if it exists, may be entirely alien to us, built on biology we can't yet imagine. Could there be creatures that feed on irradiation, or microbes living miles beneath the surface? These ideas challenge everything we thought we knew and inspire bold new scientific directions. Whether the planet holds microbial life or advanced civilizations, its discovery shifts the conversation. What would it mean for our understanding of evolution, biology, and our own place in the cosmos? As we prepare for future missions beyond our solar system, our ethical frameworks must evolve. We face a delicate balance between discovery and preservation, between reaching outward and protecting what we find. Proxima b is a symbol of that balance. It reminds us that the choices we make today, how we explore, what we protect, and what we risk, will shape the legacy we leave behind. While the possibility of alien life is exciting, this journey also holds a mirror up to us. In looking for life elsewhere, we are also seeking deeper truths about our own existence. What kind of species are we? What values do we bring with us when we venture into the unknown? The search for life on Proxima b may not just redefine our science, it could reshape our philosophy and our shared human story. This isn't the first time humanity has looked to the sky with wonder. For centuries, people have watched the stars, imagining distant worlds and alien civilizations. But in the 20th century, those dreams became reality. In 1957, the Soviet Union launched Sputnik 1, the first human-made satellite. Just a few years later, Yuri Gagarin became the first person to travel into space. America soon followed with Alan Shepard and John Glenn, setting the stage for the Apollo missions and humanity's first steps on the moon in 1969. That giant leap for mankind wasn't just about reaching the moon. It was a declaration that humanity was no longer bound to Earth. Space stations like Salute and Skylab extended our reach, teaching us how to live in orbit. NASA's Space Shuttle program turned spaceflight into a routine, at least for a while. The tragedies of Challenger and Columbia reminded us of the costs. But we pushed forward. The International Space Station, a global effort, became a beacon of cooperation and a laboratory for science. Then came the next wave. Private companies like SpaceX and Blue Origin reignited public interest. Reusable rockets and plans for Mars. Missions once again made the impossible seem inevitable. With NASA's Artemis program, humans are preparing to return to the moon and someday reach Mars. These milestones build on decades of trial, error, and triumph. They prove that we are capable of more. As we look outward, we must not forget what we've gained here. Space exploration has led to GPS, better weather forecasts, medical advances, and even new materials used in everyday life. Every step into space has echoed back with real benefits on Earth. But now, the stakes are even higher. We are not just reaching for rocks and data. We're asking who we are, where we come from, and what comes next. Proxima B may not have all the answers, but it's pushing us to ask better questions. It challenges us to dream bigger, to tread carefully, and to think deeply about our place in the cosmos. Whether it harbors alien cities or just barren rock, its discovery is a turning point. In reaching for the stars, we're not just exploring space, we're defining what it means to be human.